Hey there everyone, welcome to Sarv's classes. So here we are going to discuss about one very important question from RBI DEPRS, RBI DEPR question paper. And this question is about random sampling with replacement and random sampling without replacement. Okay, so we are going to derive the expectation of sample mean, that is E of x bar, and variance of sample mean, that is V of x bar, in case of this and this. So we are going to study about two cases, case 1 and case 2. So before that, let us first write down the first following things, that is, let us consider a population with n number of observations such that the population is x1, x2 up to x capital N, right? Now this is a normally distributed population with mu as mean and sigma as variance. Now from this capital N population, let us take small n number of sample such that we have x1, x2 dot 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 xn number of sample. So here the sample mean is equals to 1 by n summation I is equals to 1 to n of small xi, and variance of xi here is equals to 1 by n summation I is equals to 1 to n xi minus x bar whole square, right? Now let us write on the general formula of sample mean, that is Ex bar. Now Ex bar is equals to E of, this is our Ex bar, so 1 by n summation xi is equals to 1 by n summation E of xi. So let's say this is equation 1. Now this we are going to find out in case of random sampling with replacement, that is case 1, and without replacement, that is case 2. So this remains equation 1. And variance of x bar is equals to V of 1 by n summation xi minus x bar whole square. Now this can also be written as, we know that variance of xi minus covariance of xi comma xj, right? Now since here we have 1 by n, so obviously here I am going to have 1 by n square, and I'm going to take summation till n, and here we have xi xj, so here I'm going to put double summation. Okay, so to write it in a better manner, let me just clean it out. Alright, so the formula for variance becomes, see, this is 1 by n, so this becomes this summation of I is equals to 1 to n variance of xi, right, minus of we have xi and xj, as I'm going to take the combination of these two, that is the correlation between two variables, so there will be two summations, right, that is one for I, one for j, and I not equals to j. So this is our second equation. So we are going to test and find out the value of this and this with respect to with replacement and without replacement. So let's start with case 1. Case 1. So in case 1 we have random sampling with replacement. So what is random sampling with replacement? It means, suppose in a bag you have 10 balls. So suppose you are drawing one ball, right? So during the second draw you are going to put the first ball back. So that is, I'm replacing whatever I am taking back, so that at every draw I am going to have 10 balls. So first draw probability of drawing ball in the first draw is 1 by 10. So after drawing the first ball, I am putting that ball back. So I'm replacing it. That means during the second draw, I still have 10 balls. So during the second draw, I will still have 10 balls. So the probability will be still 1 by 10. That means if we continue it for 10, then the probability of drawing ball from n number of population each time with replacement will be 1 by n. Okay, so from here the first thing is probability of x r is equals to x is equals to 1 by n. That means for every value of r, that when I'm drawing it from the urn, the probability is going to be 1 by n. So therefore our exi is equals to how much? Let's go here. Let's check here. So basically I'm going to find out ex bar. So for that I need to find out exi, and then I'm going to put the value here. So we know the expectation value is what? Expectation value is summation xi into probability. So here probability is equals to xr is equals to x, correct? Xi is equals to xr. So what happens here is equals to summation xi into 1 by n. Now this I am actually drawing from the population, so I can say this is r into capital XR into 1 by n, and this is nothing but mu, that is our population mean. So that means EXI is equals to population mean. Now I'm going to put EXI is equals to mu in equation 1. So equation 1 gives us the mean of sample mean, that is equals to 1 by n summation E of xi, right? And this is I is equals to 1 to n. Now E of xi is mu, that is our population parameter. So 1 by n summation I is equals to 1 to n mu. So n times mu is equals to n mu by n. So n gets cancelled. So the answer is mu. So in case of random sampling with replacement, that means sample mean is equals to population mean is equals to expectation of sample mean, which is mu. Okay. Now let us find out the variance. Now the variance of xi is equals to basically expectation of xi minus, so in place of xi mean I can write down mu, because we have just calculated that the sample mean is mu, so this is whole square. So the formula can here be written as 1 by n summation xi minus mu whole square, right? Now what else can I write it down here? In again by same logic here, this xi is actually being selected from the population, so I can write down is equals to 1 by out of the population summation r out of the population minus the population mean whole square. So this is nothing but our population variance, so sigma square. So this becomes 3. Now I'm going to put variance of xi in equation 2. Before that I have to find out covariance. Now let's calculate covariance of xi comma xj. So this is equals to 1 by n summation r summation s xr minus mu into xs minus mu into the probability of xr being selected comma xs being selected, correct? So this is our deviation from mean times probability, deviation from mean times probability. Now this, since these are independent, so I can write down summation r xr minus let's not write it here r, because I am writing with probability, so I have to write down expectation. That is a formula of covariance. So that is, what is the formula of covariance? Covariance is expectation variable minus mean into the probability. So now let us calculate this expectation. So if we calculate this expectation, what do we find here is equals to expectation of this is xr minus mu times probability of xr is equals to x, and another one is xs, and with that this, so that is xs minus mu into probability of xs is equals to s, right? Now if I remove e here, I am going to instead put summation. So for me here the formula now will become summation r summation s, that is xr minus mu. What is probability of xr is equals to xs? Very initially we have written, in case of with replacement I am going to put 1 by n. So this becomes 1 by n into again xs minus mu into 1 by n. Now again what we are going to do, now let us write down summation r with r 1 by n and summation s with s into 1 by n. That is, it becomes 1 by n summation r xr minus mu into 1 by n summation s into xs minus mu. Now this is summation, sum of the deviation of the observation from its mean, and we know from the property of central tendency that the summation of an observation from its mean is 0. So the value is 0, the value is 0, so curve of xi comma xj is basically 0. So that means curve of xi xj is 0 and variance of xi is sigma square. So we can put these value here in equation 2. So if I put the value here, then I will get variance of x bar is equals to 1 by n square. Variance of x I have just calculated, sigma square, minus 0. Now this is equal, there is summation till I is equals to 1 to n. So this becomes n by n square into sigma square. That is variance of x bar. So variance of x bar is now sigma square by n. Therefore, sample error is equals to root over variance of this. So, sigma by root n is the answer. So, in case of replacement, that is random sampling with replacement, the expectation of x bar, that is expectation of sample mean, that is ex bar, the answer is mu, that is the sample mean itself, and the standard error is sigma by root n. Okay, now let us calculate the same thing for case 2, and case 2 is our random sampling without replacement. That means suppose in a bag you have 10 balls. During the first draw, the probability of selecting one ball out of 10 is 1 by 10, but we are not replacing it. So during the second draw I will have 9 balls, so the probability is 1 by 9. For the third draw I will have probability 1 by 8, so that means the probability is reducing. So that is, first it will be 1 by n, then it will be 1 by n minus 1, then it will be 1 minus n minus 2, and so on. So this is how we are going to get the probability. So now let's see how we can calculate the expectation as well as the variance of sample mean in case of without replacement. So here also, just as the case 1, we have our ex bar. So basically here probability of selecting one, probability of selecting x from this is 1 by n. So from here we will get that ex bar is equals to mu, the same as before, and v of xi is equals to 1 by n square, sorry, v of xi is equals to 1 by n summation xr minus mu whole square. So after calculating we will get sigma square, just like we have done in case 1, right? So we have this, that is, in case of random sampling without replacement, the sample mean of sample mean is mu, and in order to find out the variance of sample mean, we have first term, that is vxi sigma square. Now we are going to calculate the covariance in this case, right? Okay, so covariance of xi comma xj is equals to summation r summation s xr minus mu into xs minus mu of probability xr is equals to x comma xs is equals to x. Now since this is without replacement, that means if when I am drawing rth term, so the probability will be 1 by n, but during the next draw, that is not r but s, the I will have 1 by n minus 1 as probability, right? So now I can put this as the following, that is 1 by n into n minus 1 summation r summation s xr minus mu into xs minus mu. Okay, so now this is a summation of multiplication term. Now let us go to the basics of our maths, right? The formula where we know that x1 plus x2 whole square, right? If we take a formula of whole square, what do we get? We get x1 square plus x2 square plus 2x1 into x2. So that means this term, right, this into term is our covariance. So what can we write this into term? That is 2 of x1 into x2 is equals to basically this whole square term minus the summation of single term, right? That is summation, I can say xi square. So this is summation of the whole square minus summation of the square term, right? So using this formula, so this is just the formula we have used. So let me just cover it like this, the rough work. So this is rough. That is the formula we have done. So that means I'm going to put this here. What I'm going to do, so this is summation of into, that means what I'm going to get? Summation of whole square minus summation of the square term. That is cov of xi comma xj is equals to 1 by n into n minus 1 summation r summation s. Sorry, not summation here, because that is what we are going to use the formula. So in place of summation of this, what we are going to write down? We are going to write down summation xr summation xr minus mu. This is our term. So the whole square, right? Summation and the square term minus xr minus some square is summation. So the first term is a whole square summation, whole summation. See, summation and whole square, and this one is square summation. Okay, so we have used this formula. So now what can we write down here? Now xr minus mu whole square. This is basically our summation of xr minus mu. That is summation of variable from mean. So the value is 0 square. So we have 1 by n into n minus 1 into 0, right? Minus xr minus mu square summation is nothing but sigma square, right? So now what we have got here is basically the following answer. That is 1 by n into n minus 1 into minus of n sigma square. So n gets cancelled. So the value of covariance that we have got is 1 by n minus 1 into minus sigma square. Now we will put the value of, so and variance of xi we have already calculated above, that is sigma square. So now I'm going to put this and this value in the equation of variance of x square. So what is the equation of variance of x square? That is 1 by n square summation of variance of xi minus summation plus summation of xi xj. Let's put the value. So we have 1 by n square. This is n sigma square plus, now just now we have got, so that is your summation here is what? Ij, I not equals to 1. So if the probability of xi is n, 1 by n, then the probability of xj is 1 by n minus 1. So what can I write down here? Plus n into n minus 1, and the values. What are the values? The value is minus sigma square by n minus 1. So here let us simplify. This is n sigma square by n square plus n. Let's not write it plus because we have first minus sign here. So this is minus n into n minus 1 into sigma square by equation, what do we get? We get here this also gets cancelled. So right, so we have n here. That means I can take sigma square by n. So here let me write them clearly. So I've taken sigma square by n as common, and here I actually have 1 minus n minus 1 by capital N minus 1. Let's simplify. So this is n minus 1 minus n plus 1 by n minus 1, and we have sigma square by n. So this is sigma square by n. 1 minus 1 gets cancelled. So this is n minus n by n minus 1. So this is the variance of sample mean. Therefore, standard error of sample mean becomes sigma by root n times root over n minus n by n minus 1. So that means, to conclude, random sampling, in case of random sampling with replacement and without replacement, for both the cases, EX bar, that is the expectation of sample mean, is same, that is equal to the population mean. But the variance of X bar in case of with replacement is just sigma by root n, and in case of without replacement, we have sigma